Welcome to Chapter 8. In this chapter you're going to be learning about algebra, a lot about how to write and graph equations. But before we get that far, we're going to have to learn about functions and what they have to do with equations. So let's start out with what a relation is. A relation is a pairing of numbers in one set with numbers in another set. And I'm also going to let you know another way to call, or two ways to call those sets. So a pairing of numbers in one set and that first set is called the domain, or the input, or the x-coordinates. Okay, so that's the first set. And we're going to compare those with the numbers in another set. And that is called a range, or output, or y-coordinates. Okay, so mostly when you're dealing with functions, you're going to use the terms domain and range to compare sets. You've seen them before listed as input and output. Remember, we've made those T-charts, and you'd have the inputs on one side and the outputs on the other. They would give you the inputs, and your job would be to find outputs. Well, this is the same thing. Domain and range mean the same thing. So your first step on your work is to identify the domain and range. You do not have to write this down, this chart down. You're just going to have to show the work later on. Okay. So this says, identify the domain and range of the relation represented by the table below, which shows the number of miles traveled after different numbers of hours driving. So they're just going to want you to list the domain and the range. So you're going to have to decide what the domain and range is, or the x and the y values. Here, my x values are the number of hours. The number, depending on however many number of miles, or excuse me, depending on the number of hours we went, the number of miles changed. There's a relationship here. So the domain, and watch how I list this, is just 1, 2, 3, 4, and 5. It's not listed any way special, it's just a list. And then the range is 60, 100, 160, 210, 270. Pretty simple. Okay. Next, they're going to ask you how to represent a relation. So this is representing a relation. There are a bunch of different ways to represent a relation. We've already used one of them. One way, I'm just going to list them over here, is to use ordered pairs, which they're going to be giving to you here. Another way is using a table, and in the last example they listed the relation in a table, and then we could identify the domain and range. On your homework, you're going to be using a graph, you'll also be using a mapping diagram. Okay. So we have some ordered pairs here, and we're going to represent this relation with a graph and a mapping diagram. So our ordered pairs are 2, 0, 1, negative 1, 2, 2, 0, 0, and negative 1, 1. Let's first represent this using a graph. This is simply just the x and y axis, and you're plotting these points. I'm going to use some straight lines. It's probably important for you to use a straight edge or a ruler to do this as well. Okay, so my ordered pairs are 2, 0, 1, negative 1, 2, 2, 0, 0, negative 1, 1. So if it looks like we are connecting the dots here, this is actually called a parabola. You would have it wouldn't be a straight line, but a line that goes up towards here and a line that goes up here. It's kind of a V or U shaped. But this is representing this relation, a simple graph just like this. You don't even have to connect the ordered pairs. The other method is a mapping diagram. You have the domains listed on one side and the ranges listed on the other. You can use domain and range, or you can use input and output. I'm going to use input and output. Okay, so the different inputs, or the different domains that I have are 2, 1, 0, and negative 1. I'm going to put them in order. So I'm going to go negative 1, 0, 1, and 2. You can go from least to greatest, greatest to least. It doesn't matter. Same with the outputs. I am going to put them in order because I want least to greatest. On the inputs, I have to do the same with outputs. So 0, negative 1, 2, 0, 1. So negative 1, 0, 1, and 2. This is called a mapping diagram because you're going to have to draw lines to connect the ordered pairs. So here I have 2, 0. So I'm going to take 2 and 0 and connect them. 1, negative 1. So 1, negative 1. 2, 2. 0, 0. And negative 1, 1. It's okay that the lines cross. Okay. We've only talked about relations so far, so let's move on to what a function is. Let's start with the definition. A function is a relation where each input has exactly one output. A function is a relation, meaning there's a relationship between the input and output, where each input has exactly one output. On your homework, you're going to have to identify if relations are functions or not. So I have two examples here. This first example, I have ordered pairs of 160, 2 100, 3 160, 4 210, and 5 270. we talked in the beginning of this video that there's different ways to represent a relation. Well, here's one way to represent a relation, but it's hard to tell if it's a function by using ordered pairs. It's easier to tell if it's a function if you use a graph or a mapping diagram. I'm going to start with the mapping diagram. You don't have to use both, unless if the directions ask you to. Okay, so I'm going to list my inputs and my outputs. Output, I spelled that wrong, sorry. Much better. Okay, so my inputs I need to go in numerical order. It looks like I have 1 through 5. And same with my outputs, they have to go in numerical order, and they're already in numerical order for me. And then I'm going to map, I'm going to connect the ordered pairs. So I have 160, 2 100, 3 160, and then I have 4 210, and 5 270. So let's look at the definition. A relation where, function is a relation where each input, all these inputs only have one output. Okay, so we would know that these ordered pairs represent, or this relation represents a function because each input only has one output. Now let's say we had an ordered pair of 160 and 100. So this line would go from here to here and from here to here. This one would have two outputs, so it would not be a function. I'll show you one coming up. So we would say, yes, this is a function. So that's one method you can use. The other method is using a graph and something called a vertical line test. When I'm graphing this, yes, I could do the whole coordinate grid, but I'm going to realize that all my ordered pairs are in that first quadrant. So when I make my coordinate grid, I'm not even going to bother with the other quadrants because these numbers are so high. My x values are 1 through 5. This would be easier to do if you were using graph paper. That's your choice. I'm going to go up by 50s for my y coordinates. 50, 100, 150, 200, 250, 300. Now I get to plot these points. So I have 160, 2 100, 3 160, 4 210, and 5 270. When you're checking to see if a function, you are going to connect these points. Okay, so the vertical line test, you're going to think of, maybe you're going to take your pencil or something straight. I'm going to use a marker here. You're going to go along your function or along your equation and check to see if your line crosses your vertical line twice. So do you see how my green line, if I hold my pencil vertical, do you see how it only crosses the vertical line first? Because, or once I should say, because this green line only crosses the vertical line once, it would be a function. Now you may use either method. You may either use a mapping diagram or the graph. You don't have to use both. So let's do one more example of this. I want to show you the opposite of what this would look like if it's not a function. So our next example is 2 0, 1 1, 2 2, 0 0, and negative 1 1. Let's use the mapping diagram first. I'm going to list my inputs and my outputs. Looks like my inputs go from -1 to 2. And my outputs have 0, 1, and 2. Okay? I'm going to draw these lines. So my first ordered pair is 2, 0, 1, 1, 2, 2, 0, 0, and -1, 1. Okay, so now I have to check to see if it's a function. Every input only can have one output. So this -1 has one output, that's okay. 0 has one output, so that's okay. 1 has one output, so that's okay. But do you see how 2 has two outputs? This 2 has an output of 2 and an output of 0. Because 2 has two outputs, it is not a function. That's a red flag. Now, outputs can have two inputs. For example, this is allowed. But inputs could not have two outputs. Okay, let's say you prefer the graphing method. So I have to make a coordinate plane. This time, I'm going to use all 4 quadrants. And graph these points. 2, 0, 1, 1, 2, 2, 0, 0, -1, 1. So it'd be kind of hard to draw a line in between. You can if you want. We could still do the vertical line test without connecting these points. So again, I'm going to take my pencil or whatever straight thing, and I have to go across and make sure that these points don't appear twice on this vertical line. So here I only have one dot, so I'm okay. Here I only have one dot, so I'm okay. Here I only have one dot, so I'm okay. But do you see how when I get right here, I have 2 ordered pairs on my vertical line? That is not allowed. Maybe we did connect the dots and it looks something like this. So you can see how our equation only passes through the vertical line once until I get right here. Our green equation passes through the vertical line test twice. So no, that's not a function. Okay, so make sure when you're working on this work that you read the directions very carefully, because they're going to tell you whether they want you to use the mapping diagram or the graphing method on some of the problems.